Okay, so let's go through the calculating density using this PBS website. So when you open it up, make sure you click Turn Fluid into Water. And then notice that the fluid density is now 1 gram per milliliter because the density of water is 1. That's going to be important here at the end. Okay, so it says fill in the chart below by either placing the block in the graduated cylinder for volume or on the electronic balance for mass. For volume, you'll be finding the volume using water displacement. The initial volume in the graduated cylinder is 25.5 milliliters, and you can see that's already filled in for you in the box right there. So that's already in there for each of the substances. You'll need to place the block in the cylinder, wait for it to stop moving, and record the volume after. Take the final volume and subtract the initial volume to find the volume of the block. And then calculate the density of the substance based on your data. Okay, so I'm going to do a couple of them with you. So let's select gold. Okay, so there's gold. And notice it dropped to the bottom. And the volume on the flask, volume on the graduated cylinder is 27.6 milliliters. So that's going to go on the line. Okay, and then you can go ahead and subtract 27.6 minus 25.5. And that will give you 2.1 milliliters. So 27.6 minus 25.5 gives you 2.1 milliliters. Okay? So then what you need to do now is you're going to take the gold and put it on the balance. And it says 40.53 grams. So that's going to go in the next box. Okay, so then we can calculate the density. You're going to take the mass, and you're going to use this volume, the volume in the box, the 2.1 milliliters. Okay, so it's going to be 40.53 divided by 2.1 milliliters. Okay, the volume in the box. Notice that every time I write a number down, I write the unit with it. Okay, because these are measurements. All right, so they should always have a unit with them. So 40.53 divided by 2.1 is 19.3 grams per milliliter. Okay, so grams slash ml or grams over mLs, it's the same thing. Okay, let's neaten this up a little bit. Gram slash ml. Looks a little bit better. All right, let's move down to ice. All right, don't forget to go back up and do lead. Okay, but let's go ahead and do ice right now. Because I want to do one substance that sinks and one substance that floats. All right, so when we select it, we were on the balance. So let's go ahead and write down 9.2 grams for mass. And then let's go ahead and put it in the water. Now ice floats. So when we put it in the water, we want to make sure that we get the volume before it comes back up to the surface. So let's drop it in. So 35.5. 35.5 is what we want to write for the volume. So if you have a substance that floats, make sure you get the volume when it's completely submerged before it comes all the way back up. All right, so let's go ahead and do that calculation. 35.5 minus 25.5 is 10 milliliters. Okay, so we're going to find the density. We're going to do 9.2 grams divided by 10 milliliters. And that gives us once we plug it in. 0.92 grams per milliliter. Okay, so there's two examples for you. You'll need to do lead, iron, wood, and rubber on your own. Number 4 says, what do you notice about the densities for all of the substances that sunk in water? Well, the gold sunk in water and its density was 19.3. Okay, and what you'll find is that all of the things that sink in water have a density higher than 1, because the density of water is 1. So if it's more dense than water, it will sink. And ice floats in water. Okay, so we can see that ice is floating, and its density is 0.92. So you watch it float back up. Okay, so we know that ice floats, right? We can see that on an everyday basis. So its density is 0.92, which is less than 1. And so the density, if the density is less than 1, which is water, then it will float. So if it's more than 1, it'll sink. If it's less than 1, it'll float. Okay, so then go ahead and answer the rest of these questions on your own. Let me know if you have any questions. You can send me a message.